Screen is visible, right?
Yes, sir.
Yeah, here duality. What do you mean by duality? Two networks are said to be the dual of each other when the mesh equation of one network are the same as the node equation of other. In the sense, if you are having one network, whatever the network may be, it will be having 3 loops, 1 loop, 2 loop, doesn't matter. But whenever we are writing the mesh equations of that network has to be same for the node equations of other network, then it called duality, where I can say Kirchhoff's law, KVL law of one network is same for KCL of other network. Is nothing but here I can say mesh equations of network is same as node equation of other network. Fine. Now, how we are going to say the dual of voltage source will be other network. These are see here first in a loop basis, that is mesh equations. If current source is there, then we are going to replace that with voltage source. Fine. If resistance is then branch current is replaced with branch voltages. Then mesh will be replaced with node. Then short circuit, if the short circuit is here in the first network, if we are going to write the dual of that network, then we are going to replace that short circuit with open circuit. Then parallel path is replaced with series path. This one we already seen in the last classes. Okay. Now, if I am going to consider one network here, if I am going to consider one network here, this is my network, capacitor is there, then resistance, here on voltage source, and inductance R1, C, L, R2, then phi. This is the network given. We have to draw a dual of this network. Now, see this table. Tell me, voltage source will be replaced with
Current source.
current source. Resistance is replaced with conductance. L will be replaced with C. C will be replaced with L. Okay. Now, on this basis, we are going to write on dual of this. See here. Now, first step, what we need to do, we have to place, there are few steps we need to follow this for easy understanding. For this network, first step to write the dual in the sense, first I am going to place a node in the two loops. I am going to place one node in one loop. Here 2 loops are there, so I am placing the dots or nodes in that loops, and one more outside the loop. This is, I can call it the datum node or a reference node. This is the first step. Okay, if I am having, see here, if I am having 3 loops, then I need to place one dot in all the loops and one reference node outside the network. Okay, now here for this example, you are having only 2 loops, so 2 dots inside the loop and one outside the network. Now next, second step is we need to connect these two nodes. We need to connect these two nodes with dashed line. See here, we need to connect internal nodes dashed line. Okay, next, one more node is there at the outside of the circuit. Again we are going to datum node or a reference node. These two nodes what are placed in the inside the loops. We are going to connect this reference node by passing all the or branches of loop 1 as well as loop 2. Okay, first step, place the dots. Okay, 2 loops, 2 dots, 1 reference node. Then connect those inside dots with a dashed line. Then that 2 dots will be connected to the reference node while crossing the other branches. Fine. Now replace all voltage source to current source, resistance to conductance, inductor to capacitance, capacitance to inductance. Okay, here 2. I am going to name 1, node 1, node 2. Here this is a, see here, this is my node 1, this is my node 2. Okay, in between node 1 and node 2, what is there? What is there? In between node 1 and node 2? Yes, there is one passive element in between node 1 and node 2. Okay, what is that?
Capacitor.
Inductor.
This is inductor. Inductor is in between node 1 and node 2. So we are going to replace, yes, we are going to replace with C. Place capacitance in between node 1 and 2. Instead of inductance, I am placing capacitance. Next, this node 1, by visual inspection, we can see that for this node 1 is the resistance. Fine. Before that, we are going to replace this voltage source with
Current source.
Current source. Here how we are going to mark this? At the tail side it's a negative, okay, at the head side it's a positive. We know that if plus minus is there, then the symbol of the current source inside that circle will be like this. Then if like this, then symbol will be like this. Fine. Now next, one more resistance is there with this 2, that will be replaced with conductance, that is G2. This is current source I. Here this reference node. Fine. Now this R1 is in parallel with node 1, which is inside the loop 1, that is R1 is replaced with G1. Then same, we can see this node is parallel with this capacitor, so I'm going to write inductance instead of capacitance C. This is L. I can say this networks, network 1 and network 2, dual of each other, dual networks. Okay. Now we will see another example with 3 loops. This one understood, guys?
Yes, sir.
Now
Yes, sir.
screen is visible.
Yes, sir.
Yes, sir.
Now one more example you can see. Here the network is given like this. This is current I, this is R1, this is C1, this is C2, L1, R2. This is the network given. Screen is visible.
Yes, sir.
Yes, sir.
We need to draw a dual of this network. Here 3 loops are there. First step, what we need to do? Tell me. First step.
Taking the notes, sir.
Place the nodes
Placing
in
the
the
nodes
mesh.
inside every
No,
loop.
mesh.
1, yeah, 1, 2, 3. Okay. Node 1, node 2, node 3. Next step.
One reference
Connect.
note, sir.
Yeah, one reference node. Fine. Going to mark it as 0. 3 loops are there, 3 nodes, one reference node outside the network. Next step,
So connect all the inner
connect
nodes.
all inner nodes. Yes. Next,
Sir, connect the outer node, sir, with outer branch, sir, through outer branch.
yes. Here for node 1, this I'm going to connect to reference node 1. Okay, now for node 2, means we need to connect all the nodes with the reference node. For node 2, then node 3, the branch with capacitance C2, we need to cross that also. Here we can see here, this is one branch, this is one branch. Okay, this is crossed by node 2, this branch is crossed by node 1. Okay, and this C2 branch is crossed by this node 3. Means here, first step, place the nodes in all the loops, connect all internal nodes with a dashed line. Then we need to connect all the internal nodes to the reference node by crossing all the branches. Okay, here I crossed all the branches. First node for source, current source, second node for C1 and R2. Okay, then third node C2 and R2. Now we have to replace current source with voltage source first. We need to write first the nodes here. See. Sorry. 1, 2, 3. 3 nodes, 1 reference node. First, we need to replace current source with voltage source. Node 1, 2, 3, reference of 0. Okay. First, I am going to replace that current source with voltage source. Plus minus. Minus is at tail, plus at arrowhead. Okay. Next. In between node 1 and node 2, resistance is there. We have to replace that one with G, conductance. R1 is replaced with G1. Again, in between node 2 and node 3, inductance is there, L1. Okay. We need to replace that one with capacitance, C1. Okay. Now, see here, in the reference node and the node 3, in between these two, resistance is there. Then I am going to replace that one with conductance, G2. Okay. Now we can see this C2 is in parallel with node 3 and C1 is in parallel with node 2. By visually seeing, we can say that yes, these capacitors are in parallel with node 2 as well as node 3 respectively. Correct. C1
L1.
yes, L1, and for this understood? Fine. If you given any of the network, now you are able to write the developed network, right? At least say yes. I have to see some confidence in you.
Yes, sir.
Yes.
Yes, sir.
Only simple way to remember: replace current source with voltage source, replace resistance with conductance, replace inductor with capacitor, replace capacitor with inductor, replace short circuit with open circuit. Means finally what we need to get: the mesh equation of this network. That means KVL of this network will be KCL of dual network. Okay, now so any of having